What is up, team? I am the Masters Math teacher, and in this video we're going to learn about piecewise functions. So jump on board and let's get into it. So piecewise functions are pretty much exactly how it sounds. It's pieces of different graphs put into one function. Let's take a look at an example. So we've got f of x equals, so the function of x, then what we do is we write the curly bracket, the set bracket here. Then we write what does f of x equal for each part. So I'm going to say it equals x, and I'm going to say it equals x for x greater than 0. Then I'm going to say that it equals negative x when x is less than 0. And I'm going to say this is less than or equal to 0. And I'll explain why in a moment. So what this is saying is the function x, the function of x, equals x when x is greater than 0, and it equals negative x when x is less than 0. So let's graph these. So I'm going to pull up a graph, and we're going to do them in different colors here. So for blue, we're going to look at the graph x. So if we're drawing this, this is just our ordinary straight line, y equals x. And it looks like that. If we had no restrictions, this is the line y equals x. However, we're saying that we only are interested for x greater than or equal to 0. So I'm going to draw my barrier here. And what I'm saying, so this is my x equals 0 line, I'm saying I stop here. Okay, so for this graph, for f of x, I'm only interested in this part of the graph, the top part. The rest doesn't matter. This all doesn't matter. So on my new graph, my f of x graph, so this is going to be my graph in black because this is my official graph, my f of x, it equals the blue part just here. Okay, just x greater than or equal to 0. Okay, let's look at the second part of this graph. So I'm going to pull up another graph. We're looking at the negative x graph. So I'm going to pull out green for this guy. So the negative x graph looks like this guy. Obviously going through the origin. Draw a dot there because obviously that goes to the origin. Okay, but now we're only interested when x is less than 0. So I'm going to draw my barrier. This is my x equals 0 barrier. So then what I'm saying is the only part of this I'm interested in is this top part. It's this bit over here. The rest doesn't matter. So now when I put that back on my f of x graph, I'm only interested in that part here. Okay, so this is f of x. It's saying for every x value greater than 0, we're following the blue line. For every x value less than 0, we're following the green. So this graph, where there's the two colors on it, is the official f of x graph. So this is f of x. Okay, let's do another example of that. Let's look at f of x. And I'm going to make two functions again, or two graphs. We're going to say that it equals 2x plus 1. And this time I'm going to say for x less than or equal to 1. On the other side of things, I'm going to say that it equals negative x take 2. And then I'm going to say for x greater than 1. So again, I'm going to pull out two different colors. We'll take the top one as blue. So what does this graph look like? Okay, it's a positive gradient. It's 2x plus 1. So our y-intercept is going to be up here at 1. It's going to be a bit steeper than before, so it's going to look something like this. Now this time, we are only interested for x less than 1. So what we have to do here is we have to find what is the value of this graph at x equals 1, and then look at every value less than that. So on this graph, we're looking at our wall. This is x equals 1. And we need to find the y coordinate there. How do we find the y coordinate? Well, we shove it into the equation. So we're going to go with y equals 2 times 1 plus 1. So y equals 3. So now when I pull up the actual graph, my f of x graph, I know that it looks like this. We're starting here at 1, 3 and going down. That's the only part I'm interested. All this stuff past x equals 1, I don't care about. It's not part of my graph. Right, let's look at the next part of this graph. So again, pull up a graph to visualize it first. Now let's understand what the green graph looks like. So it's negative x, take 2. So our y-intercept is negative 2. It's a negative gradient, so it's going down. So it's going to look something like this. Again, draw in the wall, and it's at x equals 1 again. X equals 1. We need to find at what y value does the wall intersect. How do we do that? Well, we sub it in. We're going to go with y equals negative 1, take 2. So I'm subbing it into the second part of this graph, the green one. So y equals negative 3. Now the only part of this graph I'm looking for is values greater than x equals 1. So I'm only interested in this bottom bit, actually, this tiny little bit down here. So the rest doesn't matter. So what we do now is on our main graph, we know the value of 1, negative 3 this time. That's going to be down here. 1, negative 3. And it goes down with a slightly less slope than the other one. Now the one mistake we made on this graph, this is only for greater than 1. So this here should actually be a hollow dot. Notice why the top one was a solid dot, because it's less than or equal to 1. So this graph with the star next to it, is my full f of x graph. I'm following the blue line for x less than 1, and I'm following the green line for x greater than 1. Now note that we labeled each of these endpoints. It's super important to label the endpoints, as when we're dealing with this, otherwise you're just starting in midair and you've shown no understanding of where the graph is beginning or ending. Okay, let's try another one, and let's try it a little bit more complex. Now before we've had just 2, but that doesn't have to be the case. We can actually have 3, or 4, or infinite, as long as we specify each region. So let's do one with 3. I'm going to say that we've got our first graph, x take 4, and I'm going to go for x less than negative 2. My second graph, I'm going to do a squared graph here, a parabola, x squared take 4, and I'm going to say that it's between x equals negative 2 and x equals 2. And finally, I'm going to say that x take 4 for x greater than 2. Alright, so again, we're going to pull up an ordinary graph to figure out what's happening with each color, and then we're going to put it all together in a main graph. So we'll do blue for the top. This is our negative x take 4 graph. So it's negative gradient, and it's got an intercept of negative 4. So it's down here, negative 4, and it looks something like this. You grab out your red, and you find the wall. So we're looking for the wall of x less than negative 2. So I'm going to draw a wall here at x equals negative 2. I'm going to find what is the wall's connection point. So I sub it into the graph. Y equals negative 2 take 4 equals 2 take 4 equals negative 2. So my endpoint here is negative 2, negative 2. Let's pull up my official graph, my f of x graph. Grab out my blue, and I'm looking for x less than -2. So all this bit doesn't matter. All the bottom bit there doesn't matter. So when I graph this, I'm going to grab my point at -2, -2, and I'm going to go like that. Okay, and noting that this actually should be a hollow dot because of course we're looking at just less than, not less than or equal to. All right, let's look at the second segment. So in green here. So the second segment, so this is a parabola. It's an x² - 4 parabola. So it's an ordinary parabola, but the turning point is down 4. So it's going to be our turning point here. And it's a smiley parabola, so it looks something like this. Now in this case, we actually have 2 key points we need to find because it's between -2 and 2. So we've actually got 2 walls here. We've got a wall at -2 and a wall at +2. Now careful when drawing your walls if you don't know where those walls intersect, because if you draw the wall up here somewhere, you might get a little confused when you find out a value that doesn't quite correlate to the way you drew your graph. So just be careful, because the point that you sub in will work. The graph might be a little skewed if you end up drawing it slightly incorrectly, but that's absolutely fine. So let's find these 2 points, the intersection points with the wall. So I'm going to do y equals -2 squared, take 4, y equals 0. So this is the point -2, 0. On the other side of things, y equals 2 squared, take 4, it also equals 0. So this one's going to be 2, 0. So now I'm going to sketch this on my original graph. I grab out the green. I know it's here. We're equal to, so it's a solid dot, and that's at -2, 0. It hits here at 2, 0, and it has a vertex or a turning point down at 0, -4. And I'm just going to connect all the dots. Okay, now we have to look at the final bit of this graph. So I'll grab out a different color, which we haven't actually used more than this color before. Let's try purple. Now I'm going to have to move over a little bit here so that we get some more room. We're dealing with the graph x - 4. So y equals x take 4. This is an ordinary straight line graph. The intercept is -4, and it's an ordinary straight line graph. Now the region I'm interested in is my x greater than 2. So I'll draw my wall at x equals 2. And I've got to find my red point. To find my red point, I shove it in. Y equals 2 take 4. Y equals -2. So this point here is at 2, -2. Now I go back to my original, or my official graph, and we know we're just looking at when it's greater than here. So I'll actually zoom out so that we can see both here. We're looking for when it's greater than 2. So with my blue pen, my purple pen, sorry, I'm just looking from here at 2, -2. Now, of course, this is a hollow dot because we're not letting it equal to, and it's going up that way. So this f of x graph is the graph of this full 3-piece piecewise function. So there's a lot of steps involved. What we have to do is figure out what each of them look like, find out where they intersect the boundaries, and then sketch them all on one graph. Now, once you become a bit more experienced with this, you don't have to draw all these 3 other colored graphs. That is not necessary for the answer. However, it is super important that you do it to start with, as it makes more sense of what's happening with a piecewise function, rather than trying to confuse yourself with lots of stuff. Now there's one final thing I wanted to go through in this video, and that's how to go the opposite way. So previously, what we've been doing is going from a function notation to a graph. What if we get given a graph and we got asked to write this in piecewise notation? So let's do that here. What we're going to do is we're going to start with the red one. Okay, so this red graph over here. Now we know that it's got this point, and this point. We also know that it's the shape of a parabola. So what we can actually say here, this is our normal parabola, y equals x squared, and it's moved up 4. So this is an x squared plus 4 graph, this red one. Where does it start? Well, we know the lowest value is negative infinity. It goes on forever that way. And it ends at this wall. It ends at the wall x equals, draw it all the way down, x equals 1. So when we're writing this in function notation, what we're going to do is go f of x equals, squiggly bracket, we've got our x squared plus 4, and we've got for all x values less than 1. Now we could have also said less than or equal to, because here we don't actually get given the hollow dots and solid dots. For this example, I'm going to make this the solid dot. I'm going to make these hollow dots. And I'm going to make this a solid dot as well. So then for this one, we're actually going to have less than or equal to 1. Now let's look at the blue graph. The blue graph's a bit interesting. We haven't seen one of these yet. It's actually just a constant line. We know that for this whole line, y equals 4. There is nothing else. There's no gradient. The gradient's 0. So this has the equation y equals 4. So that's all we're going to write in our function, 4. And what region? Well, we know that the first wall is 1. We know it's not equal to. And where's our second wall? Well, let's draw the dotted line here. Follow it all the way through. And we find out the second wall is actually at x equals 3. So to finish this, it's going to be between 3 and 1. Now let's look at the final graph. It's this green graph down here. We know it's a straight line graph. So it's the y equals mx plus c graph. However, we don't actually know much else. Can we find the gradient? I want you to pause the video and see if you can find the gradient and the y-intercept of this graph. Okay, so to find the gradient, we know gradient is rise over run. So we've risen from this point to this point. We've risen up 2. We've gone across 1. So our m equals 2 over 1 equals 2. However, careful here, this is actually a negative gradient. We're going down, it's a downward slope. So this has a gradient of negative 2. So we've got y equals negative 2x plus c. We can find c by subbing in one of the points. Let's take the intercept point here. It's a nice one to use. So I'm going to go with 0, because this has the coordinate 4, 0, equals negative 2 times 4 plus c. 0 equals negative 8 plus c, so c equals 8. So our full equation here is y equals negative 2x plus 8. And that's what we write up in our function, negative 2x plus 8. And our region, well, it's for all x values greater than or equal to 3. So that's all the information you need to tackle some of these questions dealing with piecewise functions. I'd wish you luck, but I know you don't need it. Go smash out some mathematics. And as always, if you liked this video, give it a like. If you didn't, give it a dislike. And let me know in the comments what I can do better. If you have a topic you want me to cover, let me know in the comments below.